We have this integral here, x squared plus 1 to the power of 8 times 2x. Now, if it wasn't to the power of 8 and say it was just to the power of 2, you could FOIL out the binomial, right? You could FOIL that out and it'd be fine. It's not too much work. But to the power of 8, we're not going to do that. So what we're going to do is we're going to make this into a simpler integral by substituting stuff out. All right? It's called U substitution. In general, now there's no set guidelines, but in general, whatever's in brackets is usually what you want to substitute out. In brackets or in square roots, things like that. That's usually what you want to get rid of. Okay? So we just go off to the side and we go, okay, we're going to let U equal everything that's in the brackets, x squared plus 1. And then what we're going to do is we're going to take the derivative of that. So we're going to go, okay, the derivative of U with respect to x, du dx, is equal to what? 2x, right? Just 2x. Okay. You want to put all the x's on one side and all the u's on the other side. So I'm going to multiply the dx up and get du is equal to 2x dx. The whole goal here is to get rid of all the x's in the integral and replace them with u. So anything that has an x. And this is a rigged one, so it works out quite nicely. That is du. Right? Does everybody see that? Okay. What is this? That's u, right? That was our initial substitution. That's u. So this integral is now the integral of u to the power of 8 du. No more x's in there, so we're happy about that. Do you know how to integrate that? What is it? U to the power of 9 divided by 9. So we just go, okay, well, that's just u to the power of 9 divided by 9. What do you have to put back in? Yeah. Our u value was x squared plus 1, so you plug that back in. And then because this is indefinite, we have no upper and lower bounds. What do we have to tack on to the end? And that's your answer. Because it's indefinite, we don't have any upper or lower bounds. So you have to put the constant of integration. How could you check to see if the answer is right? Take the derivative of this and see if you get that, which would be the 9 falls down, right, and cancels the 9, so it would be the power of 8. What's the inside derivative? Does that make sense? All right. So now this opens up more complex integrals for us to solve. Let's do x squared times 6 minus x cubed to the power of 5 dx. All right. What do you want u to be? 6 minus x cubed. So u is equal to 6 minus x cubed. Okay. What do we do? Take the derivative. Now what? Multiply the dx up. Sorry, what's that? You want to take the derivative so that you generate a du dx. Then you need to get rid of this dx. Okay, you want to get rid of all your x's. That's essentially what you want to do. All right. So we take the derivative of it. We get that. Does that match anything in our integral? It's pretty close. We have an x squared and we have a dx. But there's negative 3 there, right? How do I get rid of the negative 3? Yeah, divide it off. So if you divide off the negative 3, you get du over negative 3 is equal to x squared dx. My whole point is to get rid of this. So everything that I just circled in white is equal to du over negative 3. So the integral is now, this was u, so I get u to the 5th times du over negative 3. Are we with me? Okay. Are you allowed to pull constants inside and outside of an integral? You are. So we're going to pull the negative 1/3 out. So now I just have that. Negative 1/3 times the integral of u to the 5th du. Sorry? So now you integrate it first. So what's the antiderivative of u to the 5th? To the power of 6. But the 1/3 sits in front of it. It's negative, thank you. And then you sub back in your u. So I get negative, what's u? 6 minus x cubed. Yeah, to the power of 6. Over 6 times 3 is 18. Throw on your plus c, and you're done. All right?
What happens to the du?
Because then you're doing the antiderivative, right? When you do the antiderivative, that goes away.
That's the du.
That is this. This x squared dx is equal to that.
But how do we know that the x squared at the beginning was? Like, how did we just group them together?
Because it's all being multiplied, right? Because we're taking the derivative of u with respect to x. You don't look satisfied. Let's do one more. Do a trick one. Actually, cosine 5x dx. All right. You don't know how to integrate this. Up to this point, the only integrals you've done with trig involve like the integral of cos x, right? It's never been anything with a number or another function in there, okay? So we need, the whole goal here, because we only have one trig function, is to get rid of this. So that's going to be your u value, okay? We're going to say, all right, u is equal to 5x. What's the derivative of this with respect to x? No, we're just doing the derivative of 5x. It's going to be 5, right? Multiply the dx up. Du is equal to 5 dx. Now I have this bit here is u. I need to get rid of the dx. But this is 5 dx. So how do I get rid of the 5 here? Divide by 5. So now you can sub everything into your integral, and it becomes the integral cosine of u. And instead of dx, dx is now equal to du over 5. You can pull the 1/5 out. What's the antiderivative of cosine? Sine of u. And u is 5x. Tack on your plus c. And you're done. Okay? So u is usually what is inside of another function. Okay? Whether it's a trig function or if it's brackets raised to n power, things like that. Okay? I would like you to do these. This is super important because it sets up everything else that we're going to do, including chapter 5. 5 to 25 odd, please, on page 301.